Alright, so far we've talked about one data set, one variable. We found the mean of one variable statistics, the standard deviation of one variable statistics. We're going to talk about comparing two variables. So we're going to talk about the correlation between two different types of variables.
Yeah.
Correlation is just a math word for relationship. No, you don't have to copy the scatter plot. You can if you want. The important thing to note is that the x values, the stuff that goes along the x-axis, we in algebra call those independent variables. X is usually the number we plug in for. In statistics, we'll call it an explanatory variable. And the y values, the ones where when we plug in an x, we get a y, the dependent variable we call a response. Okay? If we plug something in for x, we get a response. So in this situation, in this scenario, we want to know, does the size of a diamond, the size in carats, that's how you measure diamonds. Does the size of a diamond influence its price? Okay, so looking at this scatter plot, the answer would be yes. But the thing we want to know, if it influences the other thing, that's the explanatory variable. Okay. Does studying longer influence your grade? Yeah. Does sleeping more influence your grade? Yeah. Maybe.
Possibly.
We are not going to create scatter plots by hand, but I'm going to show you today how to do them on a calculator. Quite easy. So I'm going to show you examples of 4 different types of correlation. I was going to borrow pictures from the internet, but it was giving me a hard time, so I'm going to just be an artist today. So this is the first quadrant. Something that looks like the actual scatter plot I used in the last page for an example. It has a positive correlation. This is a positive linear correlation, which means the data points on the graph look like they're forming a straight line. If you remember back to algebra, when we had a line and it went up to the right, it had a positive slope. That's why this is a positive correlation.
Yes.
Yes. As one variable increases, so does the other.
Yes.
Okay, it doesn't necessarily mean positive like, yippee, this is happening. Okay, it just means that as one increases, the other increases. So it follows then that a negative linear correlation looks something like that. As one variable increases, as the explanatory variable gets bigger, the response variable gets smaller. Yes, yeah.
I say a picture.
So if we were going to spend a lot of time, we're not going to spend a lot of time on this. Remember, this is a Florida class, not a Disney class. We could calculate lines of best fit, which I believe you did in algebra. It would be the line that represents best the data, line of best fit. We could find the equation for that line. We could use it to make predictions. We're not going to Disney, so. If something has no correlation, there's no discernible pattern. I had a statistics teacher in college say that it was like a shotgun blast. In our calculator, and again, if we were going to Disney, when we saw positive and negative correlations like this, linear ones, we'd be talking about linear regression. There are other types of regression, other types of relationships. Okay, that's like going to the Florida Keys. For example, one of them would be something like that. That would require a curve of best fit, which would probably be quadratic. It would be called a curve of best fit. So we are not really going to talk about nonlinear. It's just if there is some sort of pattern, but it's not a straight line, then it would be a nonlinear correlation. It's not no correlation. There is a relationship that exists. So, using your handy calculator, you can calculate what we call correlation coefficient. The variable we represent that with is R. our values always fall between -1 and +1. If it's exactly -1, we have a perfectly straight line going down. If it's exactly +1, we have a perfectly straight line going up. So the closer the R value is to +1 or -1, the stronger the relationship that exists. The closer it gets to 0, the weaker the relationship that exists.
Everything okay out there?
I suppose. Okay, so I want you to grab a book.
And we're off with Mr. Pickard in the afternoon.
Okay, so we're going to create a scatterplot, and we're going to find R, the correlation coefficient. So the first thing we're going to do is put the x values, the explanatory variable, in one list, and the y values, the GPA, in another list. So we need to have two lists. So we have two different variables. So go scat, edit, and put that stuff into the two lists. And then, of course, remember which list you used for what. And order is extremely important here. All right, so before we make our calculation for R, I want everybody to press the yellow second button, and then press 0. It doesn't matter.
Yes.
Press second and then 0. You're going to get the catalog. You need to scroll all the way down to the D's, and we're gonna go down to where it says diagnostic on. It's right below diagnostic off.
Fancy.
Once you get to diagnostic on, you need to hit enter twice. The first time it chooses it, the second time it actually turns the diagnostic on. So if you don't do that, when you try to calculate R, it's not going to show up. So if you're on a quiz or a test, and no, you don't have to do it. And R is not showing up, and you know you're doing the right thing, that's because diagnostic is off. You need to turn it on.
Why would you have diagnostic?
If the calculator gets reset, it defaults diagnostic. Looks like it's defaulted. Alright. So now let's press stat. Press stat, go over to calc. We're going to go down to number 4. That's linear regression. That's going to give us, I think, 4 numbers. But there's only one we're concerned with. That's R. So if you choose that, you need to put the lists in the correct order. The first list that goes in is your X values.
L1, L2.
Then the second list is your Y values. Yes.
Error.
Oh, you need to put a comma between them.
Only I knew that.
Wait. Meter and
I was checking this. I actually wanted to see if it would work with that. Good. So it gives you A, it gives you B, it gives you R squared and R. That Y equals AX plus B, that represents the line of best fit. That's the Disney class. Okay. Here we're going to just look at R. R is
I didn't get that. Yeah. Look, I went to stats, went down to 2 there, right? 4? Oh.
anybody not get that for R?
hers doesn't work.
Oh, there we go.
Thanks, Rachel.
Hey, after you have them all on the list, you know what to do? What? Stat. Add the top number in L1 and the bottom number in L2. And then you gotta do a few more other things.
Oh, yeah, there are.
So I'll explain to you.
That changed my life.
Yeah, yo. If you missed entering a data point, so an X value or a Y value, and one of your lists has 9 numbers, the other one has 10, it's not going to be able to do this. It's going to tell you something's wrong. It's going to give you an error.
I didn't need like when I didn't
You should. It worked out.
Wow, what I
You would,
because it's all in one.
really good. Now, there, I was.
Then you go second. It's 0. It's 0 again.
Alright, so what does this mean? The negative means that if there is a correlation, it's going to be going down to the right. The fact that it's 0.12, it's very small, it means that it is a very, very weak correlation. Yes, so let's check that. Everybody hit the second button. Okay. And then hit the one that says Y equals. It's above the second button.
Oh.
So we're doing the operation against stat plot because we're going to do a stat plot. So hopefully all your plots are turned off. If there's a plot turned on, go arrow down to that and hit enter. If there's none turned on, just hit enter on one of them, and then there'll be a little cursor blinking over the word on. You hit enter and it'll turn on. Yeah.
You didn't have one of them on?
One of them. It doesn't matter. So whichever one is on, there'll be an option for type. The type we're doing is the first one next to the word type. So there's options for histograms, there's options for box twister plots. When you go down, it'll say X list, Y list. You need to put the appropriate list number in there. So if your X list is list 1, it needs to be list 1.
No matter what mark you pick.
No.
What about the
Wait.
Doesn't matter.
Where do we go if we have only one on? Because I just, mine were all looking at terminal.
So once you have that information in, hit the graph button.
Oh, yeah. Looks like.
Okay. When you hit the graph button, it should give you a full 4-quadrant XY coordinate plane. It's easier to see the scatter plot if you press zoom. No. Press zoom and then the number 9. That's zoom stat.
It's a lot of stuff.
Stat. Zoom stat. Zoom number 9. Zoom 9. Zoom 9.
I can barely remember.
That's why you're going to practice. Right. So it doesn't look at all like a line, right? That's why the R value is so small. 0.12. Okay, you might see in there could be possibly a little bit of a pattern if you omitted a couple, but you know, we can't just do that. So we would probably conclude that the number of hours that you exercise doesn't really have any influence on your GPA.
I can tell about
You could, but what if you had like 1,000 data
Yeah.
points?
something like that. I was like, oh.
Yeah, we're in our situations, like we're gonna do small amounts of data because all we have is a calculator and a limited amount of time. All right.
Oh, yeah.
So, in the practice, there the directions are going to ask you to actually like draw the scatter plot. I don't need you to do that. I would like you to practice getting the scatter plot on the calculator. Okay, so that you can make a connection between what the scatter plot looks like and what the R value looks like. Because I will on a quiz and test give you pictures and say, you know, what type of correlation is this or whatever. Okay. You need to find R, and then you need to draw a conclusion in context. Like here we said, on the previous example, we said that hours exercised and GPA have a negative correlation.